Picture a grand, quiet Victorian library in London. Rain is dripping from the eaves outside, lamplights streaking across the cobblestones.
Sounds very atmospheric for a discussion about coding.
Right. Well, inside, two developers are sitting at this heavy oak table. One is a junior engineer, Timothy, and he arrives with a damp coat and this quiet, thoughtful realization.
A realization that kind of completely flips how we think about software, actually.
Exactly. And his senior colleague, Margaret, is sitting across from him, about to explain exactly why his revelation is just so profound. Today, we are unpacking a fascinating piece by Aaron Rose.
It's titled The Secret Life of Claude Code, Testing as Thinking, from tech-reader.blog.
Yeah, that's the one. And the mission for our deep dive today is to explore a massive paradigm shift. We're looking at why checking your work, whether you're writing code or maybe drafting a legal brief or sending a project email, isn't actually about catching mistakes.
It's about interrogating your own understanding.
Yes. And we'll see how AI is completely rewriting the physics of that entire process.
Okay.
Okay, let's unpack this. So Timothy sits down across from Margaret.
Right.
His actual coding work for the day, like the feature he was assigned to build, was completely finished by mid-morning. But he spent the rest of his entire day just writing tests for that code.
Which is a lot of testing.
Exactly. And he tells Margaret that the tests didn't really find bugs. They found gaps in his understanding.
What's fascinating here is the specific inventory of those blind spots. He didn't just walk in and say, the code was broken. He gives Margaret a really detailed breakdown.
Yeah, he found 3 assumptions he'd built into his code regarding the input data.
Assumptions that were completely absent from the official project specification, right?
Crazy. And he found 2 edge cases he had never even considered, plus 1 hidden interaction with an older legacy part of the system.
An interaction he didn't even know existed until he forced his new code to talk to it.
I want to pause on edge cases for a second, just to make sure we're completely grounded here. We're talking about those weird, extreme scenarios that don't happen in normal daily operation.
Like a user trying to book a hotel room for, I don't know, -3 nights.
Right, or entering 1,000,000 characters into a standard first name field. Timothy had built his feature for the happy path where everything goes right. He was completely blind to what happens when the universe acts strangely.
And he actually says to Margaret, the bugs were almost incidental.
Which is such a wild statement to make about your own software. I mean, usually the bug is the whole problem.
But Margaret doesn't even blink. She tells him he has just discovered something that takes most developers years to see clearly. She says the test is not the destination.
The thinking that produces the test is the destination.
Exactly. It is a profound reframing of professional work. Margaret is pointing out that the physical code of the test, like the actual lines of syntax, doesn't matter nearly as much as the mental friction required to write them.
The friction of figuring it out.
Yeah. The test is merely a mechanism. It forces you to ask the question you didn't know you needed to ask.
It makes me think about architecture, honestly. Testing your code isn't like the city building inspector coming in at the very end of construction with a clipboard looking to see if your plumbing is up to code.
No, it's much earlier than that.
It is the act of drawing the architectural blueprint in the first place. When you sit down to draw the floor plan, that is the exact moment you are forced to realize you completely forgot to put stairs in the house.
That's a great analogy. You didn't find a broken stair. You found a massive gap in your concept of what a house requires.
But I'm stuck on something here. If I build an app and it crashes, the bug really feels like the main event. Wait, isn't the whole point of a test to verify that the thing I just built actually works?
Sure.
So why is everyone acting like the actual failure of the code is an afterthought?
Well, it is a natural reaction, and it's the exact trap Timothy himself was caught in before this conversation in the library. He admits he always viewed testing as pure confirmation.
Right, you build a thing, you verify the thing works.
But Margaret dismantles this. She explains that an after-the-fact test only confirms that the code does what you believe it should do. She says your test is entirely limited by the quote-unquote quality of your belief.
Wow. So if my belief is wrong, the test is worse than useless.
It is actively deceptive. Let's say you're tasked with building a fire exit door, and you mistakenly believe fire doors should open inward.
Even though they definitely have to push outward for safety.
Right. But you build the door anyway. Then you write a test that verifies the door opens inward when pushed. The test passes.
Oh, man.
You feel a surge of professional pride. The system reports 100% green check marks, and the building is still a massive safety hazard.
Because an after-the-fact test just confirms your flawed understanding. It never questions if you built the right thing to begin with.
Exactly. As Timothy puts it, the test just inherits the blind spots of the builder.
Which is terrifying.
It is. And this is why tests written as an act of thinking, preferably before or during the building phase, operate differently. They force you to unambiguously specify what is correct in every imaginable environment.
And the sheer effort of mapping out those environments shines a harsh spotlight on the scenarios you literally cannot imagine.
Precisely. Which fundamentally changes how we approach the mechanics of checking our work. Because if a test can accidentally cement our own ignorance, we have to be incredibly careful about what exactly we are measuring.
Right, and this leads to a stark divide Timothy notices in his work. He sees a huge difference between testing the implementation and testing the behavior.
Yes. This is where the philosophy meets the keyboard. Testing the implementation means your test is interrogating the plumbing.
It asks, does the code do this specific thing using this specific sequence of internal steps?
Exactly. But Timothy points out that if you test the implementation, the test breaks every single time you refactor your code.
And for anyone listening who isn't living in a code editor all day, refactoring just means cleaning up the internal machinery of the code. You make it faster or more elegant without changing what it actually produces for the user.
So if you test the implementation and then you clean up your code, the test throws an error even if the end result is perfectly correct.
Just because the internal steps changed. So what about a behavior test?
A behavior test asks a much simpler question. Given this specific input, does the system produce this specific output, regardless of how it gets there?
So behavior testing interrogates the problem.
While implementation testing locks in your current solution.
Okay, think about grading a math test. Testing the implementation is like a teacher grading a student on exactly how they performed long division.
Step by agonizing step.
Right. If the student uses a slightly different, maybe even faster method to carry the numbers, but gets the perfect correct answer, an implementation test gives them an F.
Which is incredibly frustrating.
Yeah. A behavior test is grading them purely on whether they got the right answer. It doesn't matter how they did the mental math as long as the final number is correct.
That's exactly it.
But look, I get the appeal of giving the student an A for the right answer, but if I wrote the code a certain way, shouldn't I test it that exact way to make sure it doesn't break? Like, I want to know if someone comes in later and messes with my specific sequence of gears.
I hear that. Locking down every gear provides an illusion of safety. But consider what happens over time. If your test demands that specific sequence of long division steps, the implementation, you are cementing your current assumptions into the foundation of the project.
Okay.
Let's say a month later, you learn a vastly superior, more efficient way to process the data. If you implement that better method, your old test will fail.
Oh, because it's looking for the old, slow way.
Exactly. You will start to fear touching your own code base, because every tiny internal improvement triggers a cascade of red error alerts.
That sounds like a nightmare.
It is. When you test the behavior, do we get the right answer? Your test survives the internal upgrades. It catches real regressions.
A regression being when a code change accidentally breaks a feature that used to work. So a behavior test only yells at you when the machine actually produces the wrong result.
You want the test to care about the destination, not the route you took.
Okay, that makes sense. But there is a heavy economic reality hanging over this entire conversation. Margaret openly acknowledges that this discipline testing as thinking isn't some brand new revelation.
No, the software industry has known this for decades.
But the economics of time completely work against it. Behavior-driven tests take a massive amount of mental energy and hours to write. You finish building the feature, you have a deadline breathing down your neck.
And the pressure is on to ship the product.
Exactly. The time deficit is an unavoidable law of physics in software development, so the tests simply get cut or they get rushed.
And this is exactly where the physics of software development break down, thanks to generative AI. Aaron Rose introduces Claude code into the narrative here, and it flips that entire economic calculation on its head.
Because Claude can write an entire suite of tests in seconds.
It can, but Timothy immediately identifies a trap hidden in that speed.
Oh, right. He realizes that if you hand Claude your finished code and just say, write tests for this, it will absolutely do it. The output will look incredibly thorough.
But there will be implementation tests.
Right, because it's a limitation of how large language models process information. And AI operates on the context window you provide.
If you feed it a completed function, Its entire worldview shrinks to the boundaries of your specific logic.
It looks at the gears you built, assumes those gears are the absolute truth of the universe, and writes a checklist verifying that those exact gears turn in that exact way.
Yes.
Here's where it gets really interesting. If Claude is so smart and capable of churning out 100 tests in 10 seconds, why not just let it read the code and write the tests and save me a whole day of work?
Even if they're implementation tests.
Yeah. Isn't having some automated safety net better than having nothing? Isn't speed the whole point here?
Because speed without direction is just automating your own blind spots at scale.
Oof.
If your code handles the fire door opening inward, Claude will rapidly write 50 tests, proving it opens inward under various conditions. You haven't gained understanding. You have merely built a fortress around your initial mistake.
So it just makes the wrong thing harder to fix.
Exactly. Margaret's strategy here provides a brilliant blueprint for using AI effectively in any complex profession. You do not use Claude to just churn out the code. You use it to generate the cases.
Generating the cases, meaning the scenarios, the environments.
Yes. You give Claude the specification of what you were trying to achieve, ideally, before you've written a single line of code, and you ask it highly targeted questions to stretch your imagination.
The article actually provides the exact prompts Margaret recommends, right?
It does. You describe the system and ask what edge cases would a senior engineer insist on testing here? Or what input combinations have historically caused failures in similar systems?
Wow. So you aren't asking it for the answers. You are asking it to show you the questions you forgot to ask.
Think about the mechanics of how a model like Claude is trained. It has ingested millions of open source repositories, incident reports, and documentation.
It's absorbed the collective, painful experience of millions of engineers who built systems, watched them crash, and wrote down why.
Exactly. So when you ask it for historical failure points, it is running a probabilistic pattern match against a vast library of human mistakes.
It brings up boundary conditions and weird interaction effects that would normally take an individual developer years of trial and error to stumble into naturally.
You use the AI as a scaffold for your thinking. Once it reveals those hidden scenarios, then you write the behavior tests to handle them.
The AI isn't the replacement worker doing the labor, it's the scaffold holding you up so you can see over the wall.
Beautifully put.
But look, even with the perfect behavioral tests generated from Claude scaffolding, reality is messy. Things will still break.
Oh, inevitably.
Timothy experienced this firsthand. One of his new tests failed because his feature unexpectedly clashed with an older legacy system. His shiny new code tried to talk to a 10-year-old database, and they were essentially speaking different languages.
And he had no idea why it was failing.
None. But how Timothy handles this failure is just as critical as how he wrote the tests. The instinct for many developers today is to highlight the error, paste it into the AI, and demand a fix.
Just make the red text go away.
Exactly. But Timothy resists that. He does something much more deliberate. He gives Claude the failing test, the expected output he wanted, the actual output the system spit out, and the code for both his feature and the legacy database.
And he simply asks Claude to explain the discrepancy.
Right. He asks for an explanation of the mechanics, not a patched solution.
And Claude delivers. It finds the issue, a subtle mismatch in how the two systems format data, in about 2 minutes.
Then Timothy, now armed with a complete understanding of the plumbing, goes in and writes the fix himself in 10 minutes.
If we connect this to the bigger picture, Margaret distills this interaction into a framework she calls the 3 distinct phases.
Okay, let's break this down.
First, the test acts as the detector. Its only job is to notice that an anomaly exists.
Right.
Second, Claude Code acts as the diagnostician. Its job is to map the complex anatomy of the system and explain the mechanics of why the anomaly is happening.
Got it.
Finally, the human developer is the decision maker. Your job is to synthesize that diagnosis and decide how to intervene.
It's like a triage team in a hospital. The test is the MRI machine. It runs a scan and simply flags, hey, there's a shadow right here.
Right.
Claude is the radiologist. It looks at the scan, understands the intricate biology of the human body, and translates the shadow. It says, that anomaly is a hairline fracture caused by repeated stress.
And then you, the human.
You are the orthopedic surgeon. You look at the radiologist's report, consider the patient's lifestyle, and make the actual decision on whether to insert a titanium pin or just apply a cast.
Margaret notes that establishing this specific triage, team detector, diagnostician, decision maker, creates a living test suite.
Meaning what, exactly?
The tests continue to ask those critical AI-scaffolded questions long after you have moved on to other projects. They act as a permanent guardrail. This makes the entire code base safe to change and grow without accumulating fear.
I hear the value in the triage team, but look, if the radiologist knows exactly what the fracture is and Claude knows exactly what the data format issue is, why am I spending 10 minutes typing out the fix?
You're asking why not just let it fix it?
Yeah, if the AI can write the code faster and without typos, why not just say, Claude, fix it, and go grab a coffee? Why am I still the decision maker?
Because of Margaret's final and perhaps most urgent piece of wisdom here, you must always try to understand before you act.
Because if you don't,
If you habitually let the AI implement the fixes, you slowly hollow out your own comprehension of the system. You end up with a product that works, but you no longer possess the mental model of how it works.
you have abdicated your authorship.
Precisely. The developer, who uses both their brain and the AI, deeply understands the problem. They build systems that last. The developer who blindly offloads the resolution to the AI builds things that work until they don't.
And when that inevitable complex failure occurs,
Nobody knows why. Not you, and not the AI navigating a massive tangled web of automated patches.
things that work until they don't, and nobody knows why. That is a chilling thought when you consider how much of our global infrastructure, our banking, our healthcare relies on these layers of code.
It really is. It underscores why the discipline of using tests as instruments of understanding, rather than just quality assurance checkboxes, is so incredibly vital.
So what does this all mean for you listening right now? The sheer beauty of this narrative in the Victorian Library is that while Margaret and Timothy are talking about software engineering, they are outlining a philosophy for almost any professional field.
Absolutely.
If you are coding a new application, this is a direct playbook. But if you are a lawyer drafting a complex contract or a marketer architecting a multi-channel campaign, the underlying principle is identical.
The tools we have at our disposal now, like Claude, are not there to do your thinking for you.
Right. If you use them to simply churn out the final deliverable, you are automating your own blind spots. They are there to serve as your scaffold. They are there to force you to ask the questions you didn't even know you were missing.
The application completely transcends software. In fact, Aaron Rose concludes his article with a brief teaser for the next installment of Margaret and Timothy's discussions.
Oh, yeah, hinting that they will tackle the concept of documentation next.
Right. The implication is that writing things down is far more than administrative record keeping, which leaves us with a rather provocative thought to mull over.
I am ready for it. What is it?
Well, if writing tests is actually a disguised method of forcing ourselves to think clearly and uncover our blind spots, what other mundane daily professional chores are doing the exact same thing?
Like what?
Could your routine meeting agendas, your project outlines, or even those lengthy daily emails actually be the real tests of your understanding?
Wow, so the next time you sit down to draft an email explaining a project to a colleague, you have to ask yourself,
Are you simply confirming what you already know, or are you interrogating what you don't?
that friction is the actual test. Because just like drawing up that architectural blueprint, if we use those daily chores as a deliberate tool to interrogate our own thinking, we might just realize we forgot to put the stairs in before we start pouring the concrete.
Exactly.
Thank you for exploring this Victorian library with us today and for taking this deep dive into how we test the limits of our own understanding.
It has been a pleasure to explore this with you. Until next time.